All right, so we're going to keep working on these physics style questions. This one in particular should really remind you of, let's say, like a physics 20 question. But now we don't have our formula sheet. We're actually going to be doing the work of deriving our formulas along the way and then using that to solve, right? So thinking about it more of like a calculus perspective. Okay, so if we remember, the acceleration of an object due to gravity is it's negative 9.8 meters per second squared. All right, so then our question is a stone is tossed upward with a velocity of 6 meters per second from the edge of a cliff 45 meters high. How long will it take the stone to hit the ground at the foot of the cliff to the nearest hundredth of a second? So, like I said, you guys, if you took physics 20, you definitely did a question like this. So, here's what's happening is that we're throwing a rock up and then it's coming back down again, right? And we want to know how long that took from the initial position to our end there, right? So let's just start off with our acceleration. So we'll say a is equal to negative 9.8, right? So that's an equation. So now what we want to do, if we think back, if we had the velocity function, then we'd take the derivative of that to find the acceleration function. So we want to go the other way around though, right? We want to start with the acceleration function. So now we're going to take the antiderivative to get our velocity function. So the antiderivative would be v is equal to, and then it'd be negative 9.8 t, because t is our variable, right, that we're interested in here, plus some value c. Okay, so we don't know the value of c, but we do have some initial conditions, so we can figure out c, right? So we really just need to know what t was, and we need to know what v was. All right, so we're given that, right? We have an initial velocity of 6 meters per second, and the time was at the beginning, right? This was like right when we threw the rock at the beginning. So our velocity is 6. So 6 is equal to negative 9.8 t, and then t, sorry, was at 0 seconds. And then plus c. So our c value, so those will cancel, so c is just equal to 6. Okay, so our velocity function is v is equal to negative 9.8 t plus 6. Now, just because I find it kind of neat, and I just wanted you to see the connection, do you remember this equation from Physics 20? If you took Physics 20, there's a chance that you didn't. So A is equal to VF minus VI over T. See if you can make sense of that equation if we're solving for VF, right? So how does that make sense with our equation that we just found? Okay, so I'll let you think of that one. All right, so now at this point, we want to solve for the time, right? So if I knew what the velocity was right at the foot of the cliff here, then we'd be able to just solve for t at this point, right? But we don't. But we were given the height of the cliff. So if I want a position function, then again that's going to be the antiderivative of my velocity function. So let's do that. So our height function, so h will be equal to, so I'm just going to take the antiderivative of each of these pieces now. So that would be negative 9.8 t squared, and then remember we multiply by the inverse of that, right? So that's going to be like over 2. And then plus, and then this would just be 6t, and then plus c. Okay, I'll just simplify that part. So now we've got h is equal to negative 4.905 t squared plus 6t plus c. All right, so again, we just don't know c, right? But we can figure it out because we do have some initial conditions again. Our cliff was 45 meters high at the time of 0. So let's just fill that in. So the height was 45 meters. And then we have negative 4.905. And then it was at a time 0. So 0 squared plus 6 times 0 plus c. So those cancel. So we get c is equal to 45. Okay, so our equation here for our height is h is equal to negative 4.905 t squared plus 6t, and then plus 45. Now, this actually makes sense, doesn't it, right? This is a parabola that opens downward because it's negative out front and crosses the y-axis at 45. So that would be, if this was 45. And so it's a parabola that does something like this, right? Oh, pen went. Okay. So we really want to know what the time was, right? When it hit the ground, when our height is 0. Okay, so that's going to be just our next step. So we've been doing this for a while. So we'll just say 0 is equal to, and then we're going to solve for t. So 0 is equal to 4.905 t squared plus 6t plus 45. All right, so from this point, I'm definitely thinking this isn't going to factor. So our next resort is going to be the quadratic equation. So we'll say, so this is our A value, our B, and our C. So that would be our time is equal to, and it's, here I'll write it out, B's negative B plus or minus the square root of B squared minus 4 AC all over 2A. So now let's just fill that in. So T is equal to negative 6 plus or minus the square root of 6 squared minus 4 times negative 4.905, and then times C, so 45, and then all over, and then our A value was negative 4.905, and it was 2 times that, sorry, so 2 times that. So I'm going to leave this to you to plug into your calculator. Just careful with the negatives, right? That's usually where you're going to make a mistake because we have minus and negative. So this is going to become like addition in there, right? Okay. So in the end, we get t is equal to negative 2.48 seconds, and we get t is equal to positive 3.70 seconds. So only one of these is going to make sense, right? So it's going to be the positive version. So that's the time that we're going to be looking at. So just thinking about what we just found, it took 3.7 seconds for the stone after it left to hit the ground.